Welcome back, I'm that chemist, and today we're going to be ranking 50 toxic gases. So with 50 gases to rank, we're going to have to go through them relatively quickly, so I apologize if you don't get as much detail as you would have liked. For ranking these compounds, we have to consider whether or not they're actually a gas. Some of these are called gases, but that doesn't really count as a gas, so we're going to be a little bit harsher if they aren't actually a gas. Additionally, they have to be somewhat common. They have to be something that everybody knows about, maybe not everybody works with, but a lot of people know about them. Additionally, I'm going to be looking at what the NFPA rating for each of these is to help us really decide whether or not they're that toxic. Let's get started. Formaldehyde is a surprising one. You might not know this, but formaldehyde actually boils at a really low temperature, something like minus 20 degrees Celsius. So formaldehyde is used quite routinely, although it is really toxic. It can be potentially a carcinogen, and it has an NFPA rating of 3. So because it has an NFPA rating of 3, we can't be too harsh on it. I think we're going to have to put it into C tier. Now the next one is mustard gas. So mustard gas here, bis-chloroethyl sulfide. This is known as mustard gas. This is one of the mustards. A mustard generally just has something that can get alkylated. Usually this is a 2-carbon chloride, so a nitrogen mustard would be the same thing but with a nitrogen and an additional chloroethyl group. Now in the case of this, it's actually just a liquid, but it can be dispersed into a vapor. This is a chemical weapon and it causes both acute and long-term issues, so we have to be pretty harsh on it. It has an NFPA rating of 4, but because it's not a gas, we're going to put it in B tier. I apologize if that upsets you. Now the next one is nitrogen monoxide. Nitrogen monoxide, also known as nitric oxide, is a relatively toxic compound with an NFPA rating of 3. It's generally formed when you combust stuff, and one of the reasons why we have catalytic converters is to convert NO2 and NO into nitrogen and oxygen respectively. So this is a little bit toxic, but compared to the other ones, it's not too bad. So we're going to put it into D tier. Now, that being said, all of these are really toxic and you shouldn't breathe in any of these. I'm not claiming that they're safe for you to breathe in, so saying an F tier could still F you up, so do not breathe in any of these. I'm going to put this one into F tier because it's not that bad. Now, diborane. Diborane is another pretty terrifying one. Diborane has an NFPA rating of 4. It actually has a rating of 444. It's super bad in every way. It's super flammable, it's super unstable, and it's super toxic. So it's not great. I think because it has a 444, we're going to probably need to put it close to S tier, but we'll put it in A tier just because there's some really nasty compounds here. Now the next one is osmium tetroxide. Osmium tetroxide is a relatively common reagent. People are afraid to work with it because it's kind of toxic. In the olden days, chemists were more comfortable working with it even outside of a fume hood, but nowadays it's got more of a bad rap. It's only got an NFPA rating of 3 though, so I think we can put osmium tetroxide into E tier. We might change that later when we come back to it. Now hydrogen cyanide, it's a classic super toxic chemical. It's got an NFPA health rating of 4. It's pretty toxic. I mean, like, cyanide has the reputation of being one of the most common poisons, and I mean nature makes it too. Now that being said, it's pretty bad. I think we can put it in A tier. There's some other ones that are a lot worse. You can smell hydrogen cyanide and escape with your life, so I think you can tolerate it. One other thing I'm going to start doing is mentioning whether or not I've worked with these. I've worked with borane before as like an adduct for some hydroboration stuff. I've also unintentionally made hydrogen cyanide in the lab before, and I've also worked with formaldehyde a couple times. Although I haven't worked with mustard or osmium tetroxide, nor have I worked with nitrogen monoxide. Actually, I have worked with nitrogen monoxide on one occasion. Now, the next one we're going to look at is hydrogen sulfide. Hydrogen sulfide is extremely toxic. Hydrogen sulfide has an NFPA rating of 4, and this is one that a lot of people can get exposed to. So one example would be if you're on a farm and you keep all of your animals' waste in one area, that can actually build up lethal amounts of hydrogen sulfide, and there's definitely instances where farmers have died as a consequence of exposure to it. However, that being said, it plays a role in the body. You can also smell it occasionally if you're cooking food that makes hydrogen sulfide in small amounts. So you can smell it and get away with your life. If you can smell it and get away with your life, it can't go into S tier. The next one is tellurium hexafluoride. Tellurium hexafluoride has an NFPA rating of 3, at least in one MSDS sheet that I've found. It's relatively toxic. It is a gas. Because it's a little bit more obscure, I think we can be a little bit harsher on it, and we can put it into D tier. Carbon monoxide. Carbon monoxide poisoning is a thing that definitely exists. Now, we can't usually smell it, although dogs are sensitive to it, and so dogs can smell carbon monoxide. This is a good opportunity to remind everybody that you should go check your carbon monoxide and smoke detector, and if you think you don't need to do it, I'm going to intentionally just keep talking about how much you should do it. You can fast forward this part of the video, but you're doing so at your own risk. This is definitely a reminder. You need to go and check your carbon monoxide and smoke detectors because you never know what's going to happen, right? Okay, I think I've gone on long enough about this. If you haven't checked your smoke detector and your carbon monoxide detector at this point, you're sealing your own fate. Now, carbon monoxide has an NFPA rating of 3, so it's not too bad. It also has roles in the body in small amounts. Trace amounts of carbon monoxide are present in the body, so it's bad, but it's not that bad, so I think we can put it into C tier, which makes sense because it starts with a C. Now silane is an interesting gas. A lot of people who make magnesium silicate specifically do so to make silane. Now I've never smelled silane gas. It only has a health rating of 2. This can go straight to F tier, not even that bad. Now the next one is arsine. So arsine gas is relatively toxic. Actually, it's quite toxic. It has an NFPA rating of 4. I've never worked with arsine gas, and it just generally looks like a really terrible compound. Initially, arsine was proposed as a chemical warfare agent, and apparently it's also almost odorless, so it could be pretty bad. Since arsine didn't make the cutoff as a chemical weapon, and it starts with an A, we're going to put it into A tier. Now, ethylene oxide. Ethylene oxide is a gas. I didn't actually realize how toxic this was, but there is a video from the US Chemical Safety Board talking specifically about ethylene oxide contamination incidents where I believe some workers were actually killed. It has an NFPA rating of 3, so it isn't too bad. It's used to sterilize stuff that people end up being able to use, but the removal of any excess ethylene oxide is necessary before making the product available to consumers. So we can put this into D tier. Now the next one is germane. So germanium doesn't often get a lot of attention in chemistry, but germane is a really toxic gas with an NFPA rating of 4. It's also potentially pyrophoric, which doesn't help its case. It's quite toxic, so I think we can probably put it into A tier. It hasn't been used in chemical warfare, so we can't put it into S right away. Now, methanethiol. Methanethiol is pretty toxic, NFPA rating of 4, pretty bad. It's also got a really strong smell, and it can even be smelled in parts per billion. There's also been incidents where people have died, but it's rare to have an incident occur where someone actually dies. So it smells terrible, although people work with methanethiolate quite often. I actually have met the resident of SyncQuest, and he told me how whenever they needed to prepare larger batches of methanethiolate from small containers into a big container, they'd have to do it on the weekend, and he'd have to pay his employees a lot of extra money to come in and do it. They're wearing all the appropriate PPE when they're doing it, but you can still smell it everywhere in the building, because small amounts of the methanethiol will still form just through getting protonated by water. So if they did this on a Saturday, on the Monday, they'd still smell a little bit of it in the building, and so people aren't thrilled about that. So it's not too bad, but it is still pretty bad. It's still got an NFPA rating of 4, so we're going to have to put it into A tier. It's also actually a gas, so we're going to have to put it into A tier. Now, vinyl chloride. Vinyl chloride is a chemical I have not worked with. It has an NFPA rating of 3. Vinyl chloride actually has an illness named after itself called vinyl chloride illness. With an NFPA rating of 3, I think we can be a little bit more harsh in it, and we'll put it into C tier. Now, boron trifluoride. Boron trifluoride as a gas is quite toxic, but it's only got an NFPA rating of 3. So before I tell my story about this one, I just want to point out that people use BF3 ethyrate all the time in organic chemistry. It's a really common Lewis acid, but working with it as a gas is less frequently encountered. So as one of our inorganic laboratory experiments as an undergrad, we made a complex between trimethylamine and boron trifluoride, which makes a Lewis acid base complex. Now, when this class was taught prior to my class being taught it, there was an incident where a large amount of boron trifluoride actually escaped and filled the whole room, and they had to evacuate the whole wing of the building, and it ended up being a big ordeal. Fortunately, no one was harmed, but it was a scary incident for sure. Boron trifluoride, it's not too bad. It's a little bit spooky, but it's not too bad. So I think we can put it into D tier. Now, hydrozoic acid. Hydrozoic acid is pretty terrifying. It's both shock sensitive, friction sensitive, as well as being extremely toxic with an NFPA rating of 4. This one's a lot like hydrogen cyanide. You know, I think with hydrogen cyanide, we probably can move it into S tier, because if you say you're working with cyanide for a reaction, everyone goes, okay, that's fine. If you're working with hydrogen cyanide, people will think you're insane. And likewise, if you're working with hydrogen azide, people will think you're insane. No one in their right mind would ever want to work with that. I've worked with azide before, and the smell of hydrozoic acid is terrible. You get a slight whiff of it. It's not at all good. It's extremely toxic, and it causes terrible headaches. So hydrozoic acid, right into S tier. Now, the next one we have is methyl isocyanate. Methyl isocyanate is a pretty sketchy chemical. It's not really a gas, since it has a boiling point of 38, but it is relatively volatile. It's extremely toxic. Super toxic, no way to treat it. If it wasn't a liquid, it would probably go into S tier, so we'll put it into B tier right next to mustard gas. Fluorine gas. Fluorine gas is well known for being a terrifying chemical that almost no one wants to work with, both for reactivity reasons as well as toxicity reasons. I mean, when it fluorinates stuff, if you're doing CH fluorination, you make HF as a byproduct, so that, like, it's not great. Fluorine is pretty terrifying. I think fluorine has to go right into S tier in terms of being scary. Now, the next one is sulfur dioxide. Sulfur dioxide only has an NFPA health rating of 3. It's relatively common. It can be used as a solvent. Sometimes people use it as a solvent. Kind of spooky that people use it as a solvent, but it's not like too bad comparatively to some of these really awful ones here. So I think we could probably put it into D tier. Maybe, actually, if we're putting osmium tetroxide in E tier, sulfur dioxide probably belongs in F tier. I mean, another thing to consider here is osmium tetroxide is probably more toxic than BF3, so we'll put it into D tier. If you tell someone you're working with BF3 ethyrate, they'll be like, okay, be careful. But if you tell someone you're working with osmium tetroxide, they'd be like, you're insane. I mean, I think we can even be a little bit less harsh with formaldehyde. Formaldehyde's not too bad. If you say you're working with formaldehyde, people go, okay, that's fine. If you're working with carbon monoxide, everyone's terrified. So yeah, fair enough. Nitrogen dioxide, kind of like nitrogen monoxide. It's toxic for sure, but it's only got an NFPA rating of 3. It's also produced endogenously in the body, so I think we can put it into F tier as well. Now, bromine. Bromine is not a gas, even though it makes bromine vapor very easily. It's only got an NFPA rating of 3, but it is scary. But I think the reason that it's scary is it's a brown gas. The other ones could be scary, you just don't know how much is in the air, so you get that false sense of security. But bromine is like pretty chill compared to like hydrogen cyanide. Have I worked with bromine? Of course I have. I've distilled over 300 grams of bromine before, which was a little bit scary, but I'm fine. Next we have trifluoronitrosomethane. Trifluoronitrosomethane has an NFPA rating of 3. It's really obscure though, and no one really works with it. Like almost nobody ever does anything with this, but it is a beautiful blue gas, and I talked about this in my blue chemistry video, which you might be interested in checking out. I think this one probably belongs in to E tier because I don't know if we really know how toxic it is because not too many people have actually worked with it. Okay, so next we have phosphine. Phosphine is a terrifying gas. I have never smelled phosphine, but I've heard it smells quite terrible. It has an NFPA rating of 4, and this is an example of a chemical that you see in Breaking Bad. And occasionally people unintentionally form this, and it could kill them. Terrifying chemical, absolutely horrifying. This can go into S tier. Now, chlorine trifluoride. This is another terrifying chemical just for so many reasons. This is the chemical that can burn sand, and it also has an NFPA rating of 4. Terrifying chemical. I only know of a handful of people who actually work with this. I think fewer than 2 labs that I know work with this. It can be used as a chemical etchant as well in circuit board manufacturing, but quite often they use other etchants as well. So I think we can put chlorine trifluoride probably into S tier. Now chlorine. Chlorine was used as a chemical warfare agent. It's readily accessible. It has an NFPA rating of 4, but you have bleach in your house. Now you might say, well, TC, that isn't actual chlorine, that's bleach, but it can still make small amounts of chlorine. And we go in swimming pools treated with chlorine, our water's treated with chlorine. Is it bad? Yes. Is it that bad? No. I think chlorine can go into C tier because if you say what's worth, would you rather breathe in a lungful of chlorine or mustard gas? You'd say chlorine, wouldn't you? That's what I thought. Ozone. Ozone is a terrifyingly toxic chemical. We talk about its importance in protecting us from harmful radiation in our ozone layer, but when it is anywhere near anything living, it is terrifyingly toxic. You might have smelled ozone before. It's one of the particular smells you get when you have high voltage electronics. It's not a pleasant smell, but it's a characteristic smell if you ever get a whiff of it. In the amount that forms in electronics, it's usually not too toxic, but if you're ever working in high voltage applications, you need to make sure that there's good ventilation to remove any ozone that may be present. Ozone also has an NFPA rating of 4. So that's why it's going into S tier. Now, ammonia. Ammonia doesn't have that high of a rating. It has a rating of 3. There are more instances where people have died from exposure to ammonia because it's used as a refrigerant. Now, everybody's worked with ammonia if you've done any chemistry at all. And even if you haven't, you've probably worked with ammonia, even as like ammonium chloride in an ice pack. So it's not too bad. Your body gets rid of it as waste. Is it toxic? Yeah, but like not really. But working with ammonia as a gas is pretty scary. The nice thing about working with ammonia as a gas when you condense it into a liquid form is it's got a really high heat capacity, so it doesn't evaporate too quickly, but there are instances where people have died from it. I'm going to put ammonia into C tier. Actually, I'm going to put ammonia into E tier. Sulfuryl fluoride. I know of one lab that specializes in working with sulfuryl fluoride. Sulfuryl fluoride is toxic. It's unnecessary to work with it, in my opinion. I think you can get around it by using other chemicals, but some people choose to work with it anyway. It only has an NFPA rating of 3, but it's definitely sketchy. So I think because it's sketchy, we can probably put it into C tier. It's also a greenhouse gas, because of course it is. Next, we have chlorine dioxide. Chlorine dioxide is a relatively toxic NFPA rating of 3. It's got a lower lethal dose than some of the other ones here, but it's not too stable, so it quickly gets broken down. I think it's a little bit more obscure. It occasionally is present in some chemistry, so you need to get rid of it. Chlorine dioxide can also be used for the disinfection of air, so in that sense it's toxic, but it's toxic for other stuff. It can be used for decontaminating buildings, for instance. After anthrax has been used, chlorine dioxide can be used to get rid of any toxic stuff that remains. So it has its purposes. Is it toxic? toxic? Yes, it's definitely toxic. I think we can put it into C tier. Now, tritium. Tritium gas doesn't have a formal NFPA rating, at least that I could find. In the MSDSs I looked at, it had an NFPA rating of 0, but it's radioactive gas. Now, can you get vials of it that glow because they have a fluorescent coating? Yes, you can get tritium vials. I have tritium vials even, and I've given them to people before. They're fine as long as they're contained, but if you breathe in tritium, that's where issues start happening. We've actually got a couple stories on the channel where tritium gas was released into a laboratory. I'll include a link to one of those here. So tritium, it's sketchy. I mean, if you compare it to something like hydrogen cyanide, it just kind of depends on the amount. Like if you had a lung full of tritium gas, that would be pretty bad. But if you had a lung full of hydrogen cyanide, that would also be pretty bad. I think tritium can probably go into A tier. Maybe we'll put it into B tier. Phosgene, S tier. Why? Phosgene is so toxic. Phosgene is insanely toxic. Phosgene has a health rating of 4. Everybody knows how toxic phosgene is. It's one of the worst things to work with. I've unintentionally made small amounts of it before, which was frightening, but it's terrible. Phosgene, easy S tier. HF, equally S tier. I've worked with HF many times. It's terrifying. People are scared of it and they ask, oh, do you get more comfortable working with it? Yeah, you get more comfortable working with it, but it's still terrifying. Less terrified is still terrified. If it's aqueous and it's really dilute, yeah, sure, whatever, that's fine. But if it's not, that's terrifying. I've worked with HF pyridine where it's up to 70% HF in pyridine. Have I ever worked with anhydrous HF? Heck no. I would be terrified to work with anhydrous HF. It's necessary to use anhydrous HF for the alkylation of arenes, which is a frequently encountered industrial process. But man, that stuff is super toxic. Now, because HF boils at 21, it's kind of unfair to put it in S tier. Depending on where you live, maybe it should go in A tier because it could be cold. So we'll put it between S tier and A tier just to make everybody happy. Hydrazine. Hydrazine also has an NFPA rating of 4 and it smells terrible. It has a really awful smell. Hydrazine and its derivatives can cause issues as they're irritants. Hydrazine, when you're working with it even as like a salt, people are kind of scared because they're not sure if you're going to be safe with it. If you're working with it as a gas, terrifying. Hydrazine could go right into S tier. Useful reagent, but wow, is it toxic. HCl, it's stomach acid. You know, if you have anhydrous HCl gas, yeah, it's bad, sure. But compared to some of the other ones here, it's not that bad. If I had to choose between breathing in HCl vapor and like tritium, I think it would be pretty close. I think I'd still be a little bit more scared to breathe in tritium. Maybe let's start thinking about it that way. Would I rather breathe in chlorine dioxide or HCl? I would probably prefer to not breathe in either of them. However, I think we should probably keep HCl in C tier. I think that's fair. I mean, when we look at carbon monoxide and HCl in the same tier, it's kind of not fair that HCl is there, so maybe we can put it down a tier. Okay. Carbonyl sulfide. Carbonyl sulfide is like carbon dioxide, but it's got 1 sulfur. Carbonyl sulfide has an NFPA rating of 3, so it's not as toxic as some of the other ones here. It also exists endogenously as a chemical that your body produces. It's present in the atmosphere all the time in small amounts. So is it bad? Yes. Is it bad compared to some of the other ones? No. Also, I just realized I forgot to mention HCl has an NFPA rating of 3. So I think it's fair. Now, this is still kind of a debatable thing because would I rather breathe in bromine or HCl? I think it's going to be close, right? Maybe we can put HCl just into F tier. Now, radon. Radon is one of the #1 causes of lung cancer, second only to cigarette smoke. Radon forms through the nuclear decay of uranium, and so places such as basements can accumulate radon because it's a dense gas from some uranium decaying in the soil underground. And if that radon sticks around, it can cause lung cancer. So radon, sketchy. I think it can probably go right into S tier, which is kind of interesting because it's a noble gas. Now, trimethylborane. Trimethylborane is pretty toxic. It's got an NFPA rating of 4. It's extremely toxic. I think it probably could go into A tier. It's a little bit more obscure. It also has a relatively low boiling point of -20, so I think it's fair that we put it in A tier. Now, the next one we're going to look at is nitrogen trichloride. Nitrogen trichloride can form through the reaction of ammonia with chlorine. It's one of the 2 chemicals that forms in pool water, the other one being monochloramine, which is slightly more toxic. Trichloramine isn't too toxic compared to some of the other ones here. It's got a health rating of 3. If it's present in large amounts, it can be a problem, but it's usually present in water that we drink, so it's not too bad. I think we could put trichloramine into F tier for that reason. Trimethylamine. Trimethylamine has an NFPA rating of 2. That can just go right into F tier. Is it offensive? Yes. Trimethylamine's disgusting. I hate it. I've worked with it. It's a little bit annoying to work with because it's a gas and it stinks, but it's not bad compared to some of the other ones here. Hydrogen selenide, right into S tier. One brief exposure that I had to it gave me a sore throat that lasted for a couple days. Gives you flu-like symptoms. I don't know of any instances of people dying from this, but it's relatively obscure, so I think it's still fair enough to put it into S tier. If you've ever smelled hydrogen selenide, you can comment down below. I'd like to hear your stories. Fluorophosgene. Same as phosgene, but a little bit more volatile. S tier. Ketene. If you've never heard of ketene before, ketene is terrifying. Super, super toxic at really low levels. I would never work with ketene. Someone in the Discord was considering working with it, and I did everything in my power to talk them out of it, and fortunately they listened. Ketene, terrifying chemical. Do not work with ketene at all. The next one is nickel tetracarbonyl. Nickel tetracarbonyl is really toxic. It's got an NFPA rating of 4, and this is prepared through the treatment of nickel with carbon monoxide so that nickel can be purified. Because this is volatile, it can be distilled. Now, however, this is not a gas, it's actually a liquid with a boiling point of 43, so we're going to have to be a little bit more harsh for it and put it into B tier. I apologize if you're offended by that. Cyanogen chloride. Cyanogen chloride is another relatively toxic one. It's got an NFPA rating of 4, and it's been used as a chemical weapon. S tier. Cyanogen. Cyanogen is like hydrogen cyanide. It gets reduced to cyanide in the body. Toxic chemical, NFPA rating of 4. It can go right into S tier. Now, perfluoroisobutylene. Perfluoroisobutylene is kind of an interesting one. You might not have come across this one before. It can be formed through the decomposition of Teflon, and it is listed as a potential chemical weapon. So while the health rating might be a little bit lower, it's still a concerning chemical, and so we'll put it into C tier, but I'm not quite sure how well studied the toxicity effects of this are. So we're going to put it in C tier. Diazomethane. This one's pretty toxic as well. It's got a rating of 4. It can go right into S tier. Now we have sulfur tetrafluoride and bis trifluoromethyl peroxide left. Sulfur tetrafluoride is pretty toxic. I would never want to work with this because it's a gas. Shocker. Although it only has an NFPA rating of 3. It's still really toxic, but compared to the other ones, it's not too bad. I would prefer to work with chlorine over sulfur tetrafluoride, so I'm going to put that into B tier. Finally, we have bis trifluoromethyl peroxide. This one's a little bit more obscure, and I don't think its effects are too well studied. This is a stable peroxide, which might be interesting to you, and it's produced using chlorine trifluoride. So since this doesn't have a reported NFPA rating that I could find, although this is also a gas, so I think for that reason, we can put it into B tier. So hopefully you've enjoyed this video, and you might be interested in checking out another tier list. Have a great day.